All right, so we'll continue with our unit. We have a quiz coming up on Wednesday, which will cover everything we've covered so far, and also include what we're starting today, which are inequalities. I wasn't able. I should have been able to finish, but I wasn't able to finish last period because they wasted a ton of time. If you guys don't, we should be able to finish. Okay, let's compare and contrast. Equations and inequalities. Okay, they both get solved. You can see just like with equations, you solve them. Inequalities also get solved. What did we say it meant to solve? When you are solving, what are you doing? Isolating a variable, sure, and that's the same exact thing we're going to do today. And the good news is that with the exception of one little rule, in certain occasions, it's going to be exactly the same. Just like equations are two equal expressions, inequalities also contain two expressions, but what we're changing is the comparative symbol in the middle. Instead of saying that those two expressions are the same, now one expression is going to be larger than the other one. We're still going to work backwards. We're still going to do reverse order of operations. We're still going to cancel out until we isolate. Only real difference, again, there's going to be one little difference with solving, and then one extra thing that we do, and it isn't that we couldn't do it with equations, it just wasn't really valuable, was to graph. We're also going to graph. So that's fun. I thought I had included a slide here, but I guess I didn't. I have a slide where I review the different types of inequality signs. So that's fine. We can adjust, and you can just write this stuff on your notes. We'll do a little mini slide here off to the side. Instead of equations, which only contain one type of comparative symbol, which is the equal sign, that compares those two expressions, inequalities can have one of four different types of comparative symbols. I'm sure you've seen them before. They have names. But as far as, other than for the purposes of referencing them, the names don't have much value. Like as far as it comes to with solving, or for that matter, graphing an inequality, knowing the names of these isn't going to help you as much as knowing their components, like, or how they work. But just for fun, let's name them anyways. What's the first one called? Less than. Good. What's the second one I drew called? Greater than sign. The third one? Less than or equal to. And finally? Greater than or equal to. Fantastic. So let's get the party started. This first inequality says that some unknown number, v, minus 4 is less than -3. So if you've never seen an inequality before, luckily we can treat it just like we did an equation. Instead of an equal sign, the inequality sign is what splits this into two expressions. And we want to isolate, we want to get the variable by itself. So Tad, how would I do so here if I want to get that v by itself? If this were an equation and I wanted to get the v by itself, what would I do? Plus 4? Good. Add 4 to both sides. And now we have isolated the variable. So we say that v is less than 1. Okay?
It's the same thing.
That's why I started the lecture trying to emphasize the similarity between equations and inequalities. It's not the exact same thing. There's going to be a couple of minor differences. But yes, I fully expect that if you understood how to solve an equation, you should know how to solve an inequality. Okay? But now, besides solving, the other skill we're going to work on is graphing. And it isn't that an equation couldn't be graphed. It's just that it didn't really serve a purpose, because, like, let's pretend that this would have been an equation and I would have solved it, and I would have ended up with v equals 1. Could that be graph? Sure, but then on a number line, by the way, you only need one number line because there's only one variable. What's the only variable here? V. Later on this year, we get into two variable equations, which means you need two number lines, which gives you the x and y axis and all that other fun stuff. You haven't seen that before. But with one variable, you only need one axis, and I'm sure you've seen a number line in 0 and 1 and 2 and 3 and -1 and -2. By the way, I won't make you draw your number lines this way, but I'm just showing this to you because if you were to graph the solution to an equation, it would just be a point. If this unknown number is equal to 1 and I wanted to demonstrate that graphically, I would find 1 and I would draw a point on it and I'm done. It's not very helpful. There's not you don't gain too much from being able to see it versus being able to write it. But now with an inequality, what we're demonstrating is that this unknown number that we're looking for to make this inequality true can be any number that's less than 1. And how many numbers are less than 1? An infinite amount. There's an infinite amount of numbers that are less than 1. So it helps us to be able to graphically show this, to encapsulate a lot of information into a small amount of space, right? What would I need to see? I need to see the number line. Okay. Of course. So you're going to draw the number line. But instead of having to draw a bunch of extra numbers on the number line, there's only one number that's important. And that's the number that you solve for. Once I solve for v, the number on the other side was 1. Now it's important for a different reason than it was with equations. With equations, that was the solution. That was the answer. If I say v equals 1, 1 is my answer. But on an inequality, what the 1 is in fact acting as is like a barrier, a divider. It's getting the number line and it's splitting it into two. The good guys and the bad guys. The solutions and the non-solutions. It's acting like a wall. On one side, there will be solutions which we will shade. On the other side, it will be the non-solutions which we leave alone. So that's all you should really have to show, is whatever you got on the solution. In lieu of writing all the rest of the numbers, I just put the minus and the plus sign. It doesn't mean positive and negative. It just means smaller numbers go left, bigger numbers go right. So first thing you do is show me that critical point. The second thing you got to show me is what's going to happen at that point. Because that number cannot just remain as a fence. It can't just remain, it has to choose a side. We're going to force it to choose a side. Either it has to consider itself part of the solutions or part of the non-solutions, and that's dictated by whether or not you see the or equal to sign. If you see an or equal to sign, you shade it in. Shading means solution. Whatever you darken in, that means that's the answer. So if v is allowed to be equal to the number that's there, you would shade in on that number. But this didn't have an or equal to sign, so we're going to leave it empty. You're going to put an empty point, an open point. That's just a symbol for, hey, I'm not included as part of the solution. Well, we haven't got to the shading part.
I know that, but I'm just asking.
And I'm about to cite. So there's three key features that need to be included in every graph. One is the critical point I showed you, which here is 1. The second thing is what happens at that critical point, which in this case remains empty because 1 is not part of this particular solution. If I put a 1 up in here, it would not make this true. The last thing would be where the rest of the solutions are. Where are the answers relative to 1, compared to where 1 is, right? So I'll first show you some misconceptions, and then I'll show you the way I teach it, but I mean, some of you are pretty stubborn, and if you want to stick to your own way, that's fine. Just be careful if you make a mistake. So, Ashley, even though I don't hear it,
I was turning it off. Listen, but my phone's cracked and I don't know how.
oh, I
That was the
If you put it away, it wouldn't crack. It would just be in a safe place. So as Ashley was telling me before, she was like saying, "Well, but hey, isn't it like a less than sign? So, if it's less than, that means it should go left." And okay, that works sometimes. The bigger one, the one that I hear a lot of, and I think I know why teachers teach it this way, but I just don't really like it, is people that say, "Hey, look, okay, perfect. Look at that inequality sign and think of it as being an arrowhead." Yo, yeah. Well, what they're teaching you to do is to look at the closed end of the inequality. The two ways that I just mentioned, going by the name and going by the closed end, only works if the variable's on the left side. If the variable ever ends up on the right side, you're going to get it wrong. But if that's the way you want to learn it, okay, that's up to you. The way I always learned it was to look at the open end. I was taught as a little kid to think of it as the alligator mouth, but I don't draw alligators very well. But I can draw, like a Pac-Man or a Mrs. Pac-Man. So yeah, we're like, hey, the alligator is hungry, and it's given two choices. So and it's always gonna want to pick the bigger of the two. So right now, when given two choices, either this unknown number or 1, the mouth is choosing the 1, which must mean that the 1 is greater, which would mean that the number is smaller. And where do smaller numbers go? To the left. To the left. The easiest look, you're not gonna see this written down on the board, but the easiest way I can describe it to you, which will always work regardless of where the variable is mouth eat letter, shade right. Always shade right. Mouth no eat letter, shade left. Do it, Coda. Do it. Variable sounds better, but you guys maybe calling it a letter may be easier for you to remember. Ah, see, you just messed it up for everybody, Coda. Mouth eat letter, shade right. Mouth eat letter, letter big. Big numbers go. Mouth no eat letter, letter small. Yes, Claire. Okay, so let's answer the question for Claire that we just answered before. Why don't we just go where the arrow is going? When would that fail? When would that method fail? If the variable's on the right. When you solve, if this v would have ended up on this side, then trying to imagine the inequality sign as an arrowhead, then do it that way. That's fine. I'm not opposed to it. My days of trying to force kids to learn things certain ways, that those days are long. The only universal way that will always work, regardless of where the variable is if you consider the open end and whether the open end is facing the variable or not. Okay, but it's the only way that you've learned it is to think of it. That was my discussion last year. Where another student said, yeah, but my teacher said that to think of it as an arrowhead, but then if the variable's on the right, then flip it to the left, but then flip the sign also. Okay, if you want to think of it that way, you go right ahead. We're all set in our ways, and we're stubborn, and the first way we learn things is the way we want to always remember them. Fine, but if you make a mistake, that's on you. Any questions there? Okay, here's another one. You know all the answers, right? All of them. Suna, what do you want to do? I agree. We're going to subtract 6 from both sides. The 6 is on the left cancel, and we get that n is less than or equal to 4. We're going to draw a number line, and we want to include 3 pieces of information. We want to know where the critical point is. What's out of all the points on a number line, what's going to be the most important one here? 4, because 4 is going to split the number line into 2 sections. One will be the good guys, and one will be the bad guys. Yeah. But luckily, Mr. Romero's giving you a nice, quick way to do this so that you don't have to take forever and then not finish. Instead of having to write down 2 and 3 and 4 and 5 and 6, all you gotta do is put the 4. Now, what's gonna happen on the 4? What's gonna happen right on top of the 4 in this case?
It's gonna be a closed dot.
Yeah, now we're gonna put a closed dot, closed point, closed circle, whatever you want to call it, but it will be closed because this or equal to sign indicates that the 4 is part of the solution, it's part of the good guys.
Oh, Mr. Schultz, and then go to the right. And I kept my map.
And then Claire, where do you want to shade? Where do you want to shade? Coda says right. That's what Coda said.
You're gonna go right.
You're gonna go left.
Oh no.
Coda, mouth eat letters, shade right. Mouth no eat letters. Mouth eat letters.
Oh.
Is it eating the letter?
Nuha, even if you don't know how to do it, what should I do first? Okay, so once we get past the initial shock of seeing the fraction, every single person should know what to do. And Nuha, since you answered that so well about adding 3/2 to both sides, I will follow up and ask you how I would add. I'm gonna rewrite it first to make it look a little prettier. But in order to be able to add those 2 fractions, what do I need to do next? Nuha.
Find the same denominator.
Good. What's the LCD of 5 and 2?
What?
What is the LCD? What is the least common denominator of 5 and 2?
10.
Thanks, Nuha. You seem to answer a lot when I call girls' names. Well, I don't know. Is there like a girl's name that I can stick to girls' names, but at least let's pick one so that you would know that it's that because like one was Shirley maybe. I don't have Kiki. Okay, I can do that. Kiki. All right. So then if you hear Kiki, that means you can answer, but if not, that's the other. Yeah, it's a 10. So Ashlyn, 5 times what gives you 10? 2. Good. 2 times what gives you 10?
5.
Okay, so this first 3 goes times 2. The second 3 is times 5.
How do we graph it?
Oh, why would you leave it like that? Now that we have a common denominator, now we can finally add. The moment has arrived.
Wait.
How did I get the 6 and the 15?
Yeah.
The magic of technology. Watch this. Ready? The first thing I asked her was 5 times what gave me 10. She said times 2. So whatever I did on the bottom, bam! I did on the top. 3 times 2 is 6. Then
I see it now.
I want to though. Then over here, 2 times what gives you 10? It is a 2 times 5.
And 3 times 5
Look at Ashley. 3 times 5 is 50. Justin, what's 6 plus 15? It is 21. But wait, can I write it as a decimal?
No.
Well, the only real need to write it as a decimal is if you were being forced to place this on a number line where you had to fit it in between integers. Like, yeah, you'd have to know that 21 divided by 10 is 2.1. 2.1 is in between 2 and 3, but closer to 2. But since I'm not forcing you to do that, we could leave it like this. But wait, mister, but then can't you reduce though? Well, no, 21 and 10 don't have a common factor. So we leave it as is. My critical point is 21 over 10. What's going to happen on top of 21 over 10? It is going to be shaded. And then Coda, time to redeem yourself, buddy. Where are we going? Good. Why? Well, if you want to do the whole arrow thing, well, that's up to you. But I think a more comprehensive reason would be that the open end is facing the variable. Mouthy letter. All right. Yes. This is a graphical representation of all of the numbers that would make that original inequality true. If I pick any number that falls in the blue region, any number that's greater than or equal to 21 over 10, I can plug it into the original inequality and end up with a true statement.
It's always about her.
She tricked me. Deja, what do you want to do first here? Karis, what do you want to do here? I will, but I want to do something first.
Change that. I got it.
Oh, it's immediately and Kiki, though. Not even like rhymes.
My name's Funky.
Good. Change the 2 3/5 to an improper fraction. And then we can go ahead and do what Kara said, which is to subtract 3/5. And this works out fantastic. Why, Kiki? Why does this?
What? Oh, what did you do?
No. They took care of what to do part, but I just asked you what works out so conveniently about what they already did. Yeah, the denominators are the same. 13 minus 3 is 10, and then besides the fact that the denominators were the same, it also works out nicely because I have two numbers that are divisible. 10 divided by 5 is dos. You're right.
And it's open dot.
It is going to be open on top of the 2, and then where are we going to shape? To the right, good. Other than the graphing, how has this differed from solving equations so far? Yeah, how has it differed? How has it been different? Again, other than graphing, other than the fact that we are also graphing, how has this been different? Okay, I guess, but that's not. You can't tell by the way I'm phrasing it, like what direction I want to do it. Yes, Lorna?
The variable is never solved.
Subtracting fraction.
No, I'm sorry, maybe it was me. The answer I was looking for is that it really has a difference. Meaning, like, without maybe introducing those new inequality signs, which I think many of you have already seen before, it would have been reasonable. It would be reasonable to think that I could have kept my mouth closed, asked you guys to do these first four problems, and at the very least you would have been able to solve them because the steps to solving have been the same so far. So far. Okay. Keep the party going. Cassie, what do you want to do here? Cody, what do you want to do here?
I'll multiply.
Okay, let's go one more at a time. Cody said multiply. He's correct. For the first time today, we're going to multiply. Okay? Multiply by?
1.
Cody? By 4. Yeah, we're going to multiply by 4 on both sides, but keep that in mind. I don't care with what I'm starting with on the other side. I don't care what I'm going to end. What's on the other side is irrelevant at this point. The fact is I want to get rid of a positive 4 that is being divided, and I'm going to do so by multiplying by 4. And I'm kind of weirded out now because you seem to emphasize that way too much. And I ended up with 4 times negative 3 is negative 12, and still nothing's changed. Geez, that's weird. Why would you emphasize that so much? Well, keep that in mind. Again, what did we do? We multiplied, in this case by a positive 4, to both sides. That's also very important. That we did it to both sides. Now, another thing that ends up being a little bit new here is where is the variable located? On the right side. So when it comes time to graph, it's still obvious what my critical point is. It's still going to be negative 12. It should still be obvious what type of point is going to go there. It's going to be open. But where are we going to shade, Coda?
To the right.
Good. See, but I knew that. All I did was I moved the x to the left, and then I flipped the sign. Okay, go for it. If you insist, it's fine with me. No, make the fraction stop. Elizabeth, I want to solve for x. This will also should only take me one step. How do you propose that we isolate the x? We are going to multiply, but wait, that's so weird. We're already multiplying. Why would you multiply again? Sam, any idea? No way, Rose. Bryce? No. Sarah? No idea how to cancel when you're multiplying by a fraction?
You make it a fraction.
You make it a fraction. What? No.
No, not even.
I want x to be by itself. I have to get rid of negative 3 over 2. Negative 3 over 2 is multiplying with the x. Which is weird because she said to get rid of you would also multiply, but what's even weirder is that I told she was right. But I asked her what she has to multiply by. Yes. No. Thank you. The reciprocal. Multiply by that. The reciprocal. But that's something you should already know. That is not new. In order to cancel, whether there's an equation, an inequality, if you want to cancel out multiplying by a fraction, you multiply by the reciprocal. Here's what is new. What did that reciprocal end up being? A negative 2 over 3. I multiplied just as Cody said. But for the first time, I am multiplying by a negative on both sides. So I know some of you already know this, but if you don't, I dropped the x. On this side, what is positive times negative? It is a negative. 6 times 2 is?
12.
Divided by 3?
6.
Negative 4. I don't care that I'm going to end up with a negative. I don't care that I started with a positive. The important thing is I divided. I, me, yo, you, we divided by a negative. So on the next line, we flip the inequality sign. You are not going to see this written down. If right now you've turned on autopilot and your eyes are communicating with your hands, well, without actually thinking about it, and you're just writing what's on the board, I'm not going to write this on the board, but I'm going to tell this to you. If, in an inequality, if you multiply or divide, inequality, multiply or divide, negative number on both sides, you have to flip the inequality sign. Goes to the right. To the right, Brian. Kiki. Inequality, multiply or divide, negative number on both sides, flip the inequality sign. At the beginning, the open end, the mouth, was facing the left. Now it's facing the right. But what it's not facing is the variable. So, Brian, my critical point is -4. I'm going to have a solid point on -4, but where am I going to end up shading? Yeah.
I don't know what
I gave you the critical point. It's -4. That's what I ended up with. That's the point I'm going to show. I told you I'm going to shade in the point on -4. But then I asked you where else are we going to shade? Where else on the number line are we going to shade?
to the right.
Mouth, no eat letter.
Oh, left. What? Oh shoot! I mixed up my left and right. It's my bad.
It happens sometimes. Yeah, just do that. The L is.
Wait a minute.
Why? Just say it.
Because I don't know how to explain what I'm
Don't be
trying to
scared.
add. I'm
Just
not
hand
scared.
movements. Tell me.
I just don't know how to explain what I'm trying to add. Yeah.
Any
Right.
questions? No questions there?
Cool.
Did I skip that?
No, we didn't.
Alrighty then. Megan, what do you propose we do here? By? Where?
On both sides.
Thanks, Megan. Divide both sides by 4. Easy peasy lemon squeezy. You get the 3. Yes, we divided, but we did not divide by a negative number. So the sign stays exactly as it was. My critical point is 3 with an open point. Where am I going to shade?
Left to the right. Left.
Yes, as Beyonce once said, to the left.
To the left. That's my view.
Oh my god.
He only listens to songs by Gucci Gang.
Gucci Dane?
Is that what you said?
I'm Gucci Dane. He called me that one.
No, that man is not serious.
You listen to yodeling?
Right? No. That Walmart guy.
Any questions? Chooks! What do you want to do first here, Chooks? Oh, listen to what he said. Divide by -7. And where are we going to divide by -7?
Both sides.
On both sides. It does not matter that the 17 was negative. It does not matter that I'm going to end up with a positive. What matters is that I divided by a negative number on both sides of the inequality. So,
Does that mean that the sign flip?
yes, it does.
And then we flip it back at the end.
That
Negative divided by negative is positive. 17 can't be divided by 7 or reduced. But the sign does flip because I divided by a negative. So then yes, it's clear. Said, I flip the sign once, but then I want to move the y to the left, so I flip it again. So then the sign ends up facing where it started originally. And if you feel that, then do that. Then go for it. She's a rebel. If you were to insist on the variable being on the left always, and in this particular case, it would have gone back to
it goes back to what it was.
if you insist.
So it was, but that's not going to the left. And is that on? Yeah.
What Claire is saying is that like on her paper, she's not gonna write it this way. She's gonna write it.
Are you crazy? Do you not see the sign? It completely flips, so you would go to the left. Yeah, but then the y has to go back.
Yeah, but the difference is I'm writing the y on the right. She wants to write it on the left. And this thing froze on me again. Wow. I give up. If you would have just put it away in a safe place.
It was in my pocket.
I can put it away in my desk if you want, and then it's even safer. Okay, so maybe if it's better, just block it out. But what she was saying is that if she wants to write the y on the left, then yeah, in that case, the mouth would have gone back to where it started. And regardless of who wrote it what way, the critical point is still 17 over 7. It's still shaded in because it's still or equal to. And in both cases, the open end is facing the variable. So no matter what, you're still going to shade to the right. What doesn't make sense?
Because that variable is going to the left. I mean, the thing is going to the left.
You say it is going to the left. So the only thing I can fathom is that you're considering this to be an arrow, right? Is that what you're...
But that is going, but I don't think when you flip it, it's going to the right.
Correct. But the other thing that's flipping... The other thing that's flipping besides the sign is the location of... I have the y on the right side. She has it on the left. What we both have in common is where Pac-Man is facing. In both cases, Pac-Man is eating the y. That's why we're going to the right. Here, if I tell you, Mimi, that Brian is shorter than you, is that any different than me saying, Mimi, you're taller than Brian? No. Then that's the only difference. It's a comparative symbol saying one thing is bigger than the other one. In red, it's saying that 17 over 7 is less than or equal to y. And black, it's saying that y is greater than or equal to 17 over 7. But they both mean the same thing. You remember whatever's easier for you. And then now we graduate to multi-step inequalities. Raquelita. No, he's not.
Oh, I just got a paper.
Raquel, what do you want to do first here?
Exactly.
I don't know. I don't want to know. Myra, what do you want to do first? I know. Good. Subtract 6 from both sides. So then, of course, what I hear is, oh, but look, it's a negative. And if I see a negative, that means flip. No, because what did we do? Very good. Well, I only subtracted. So I'm going to drop down a negative 3p. I'm going to still drop down a greater than or equal to sign. And I drop down negative 15 because that's negative 9 minus 6. But true, what do I do next?
You divide 3p. Negative 3p.
No, you don't divide by the p. The p stays. You divide the negative 3. That's what I want to cancel.
Same difference.
No,
The sign changes.
yeah, because I divided by a negative, Claire's on top of that, so is Coda. We flip the inequality sign so we get that p is less than or equal to 5.
Why is that so big? But what?
No, ask. Go.
No. So you
True.
flip to wait. Yeah. When the last year when you changed it to a positive. You changed it to a positive. Yeah.
Because I divided a negative by a negative and it became positive.
Oh.
Over here.
Well, you did divide a negative by a negative.
Okay, and there's positive.
Oh. So that's all that's gonna be on the
Wait.
Elijah, you have a way of hiding back there. Sneaky Elijah. What do you want to do first here? Foil? No, distribute. Yeah, what do you want to distribute? Michaela, what do you want to distribute?
A negative 1.
Good, a negative 1. I'm going to distribute it. Claire. No, he said a negative 2c. I'm going to distribute a negative 1. And Claire's like, whoa, you're multiplying by a negative, so the sign's going to flip. Why not? It's not going up. I am not multiplying on both sides. I'm just performing a multiplication that was already there, so nothing happens to the inequality. Lorna, what do you want to do next?
Add the negative 7c.
Yeah, negative 7c and negative 2c is negative 9c minus 18 on both sides. 0 minus. Oh, it's a negative. Now we flip the sign, right? No. Because I just subtracted. And then Dave, what's the last step? By? Good. Divide by a negative. True, we do happen to get a positive just because negative divided by negative is positive, but flip the sign because I divided by a negative. We're all experts at graphing by now, so you know that wave spelled backwards is T-R. True. And the I sound. Three left.
We got 3 left. We gonna make it?
I don't know. We'll find out.
Wait, we have 3 minutes left?
3 problems.
We got 3 problems.
Okay, what's different here? What's different here?
X on both sides.
X on both sides. So just like with equations, let's put them on the same side. If you're going to be in the Claire camp and say variables must be on the left side, that's fine. Then what you would do first, it's fine. There's nothing wrong with it. It's fine. But you would add X.
Add 4.
I like to live dangerously, so I like to move the smaller coefficient in front of the X. What's smaller, negative 3 or negative 1? Negative 3, so I'm going to add 3x to both sides. Once I do that, the 3x's take over the right side. And if you don't have an x, you're no longer welcome. So who needs to go bye-bye?
The 6.
The foe. I started with 4 terms. I still have 4 terms, but now I have the like terms aligned. 6 minus 4 is 2. Negative x plus 3x is 2x. I divide by 2, but I'm dividing by a positive. By moving the smaller coefficient, I guarantee myself a positive. So no more need to flip a sign. And I get that 1 is less than or equal to x. The mouth is eating variable. Shade to the right. Mouth eat variable, shade right. Not thinking of it as an arrow.
No, it doesn't, bro. The mouth eats the variable.
Mouth eat variable. What you're shading is a representation of the variable. Mouth eat variable, variable big. What direction do big numbers go?
To the right.
To the right. All right, and then a little flashback Friday. Flashback to yesterday. What do we do first again? Okay, we're gonna distribute, and then I'll even fast forward to combining because we're all experts at combining right now. And here's the flashback. I go to put the variables on the same side, but regardless of which side I choose, left or right, all the x's end up canceling out. What did we learn to do when all the variables cancel out with equations? Keep pushing? When all the variables cancel out, what do we learn to do?
No solution.
No, you cannot just assume no solution. Drop down the leftovers. The leftovers here is now it's a statement of inequality as opposed to a statement of equality, but we still have to judge whether or not it's true or false. This says that the number 9 is less than the number 1. Is that true or false? So because it's false, that's why it's no solution. That's a little symbol for no solution. It's called the empty set. If there's no solution, there can be no shading, which means there can be no graph. Hold on. Still got time.
You got one more? You got one more?
One more. I got this. That's a minute ahead. So I got it.
It's a minute behind.
It is. So it's a minute ahead.
I counted.
Okay, so just real quick. I'll fast forward to this one. I distributed already, but I wanted to show you that the variables cancel out again. You drop it as if it was hot. Good. And now this statement says that the number -4 is less than or equal to 12. Is that true?
Yes.
Yes. So because I was left with a true statement, that means here that this has infinite solutions or all real numbers. Now this one could be graphed. It's just kind of pointless because if you were to graph this, what would this look like on a graph? If I were to shade all real numbers, you shade the entire number line. Yeah, that's fine.